Ground effect on takeoff. Ground effect is a phenomenon that significantly enhances an airplane's performance when it operates in close proximity to the ground, typically up to an altitude equal to one wingspan above the surface. This effect is most notable during critical phases such as takeoff and landing. When an aircraft is under the influence of the ground effect, there is a reduction in upwash, downwash, and wingtip vortices, leading to a decrease in induced drag. This reduction in induced drag is around 25% when the wing is at a height equal to 1/4 of its span and increases to about 50% at a height equal to 1/10 of the span. During takeoff, the aircraft experiences the takeoff roll, liftoff, and the initial climb within the ground effect area. Ground effect causes local increases in static pressure, resulting in lower indications on the airspeed indicator and altimeter. The vertical speed indicator may also indicate a descent. As the airplane climbs out of the ground effect area, several changes occur. 1. The airplane requires an increase in angle of attack to maintain lift coefficient. 2. There is an increase in induced drag and thrust required. A pitch-up tendency is experienced, requiring less elevator travel due to an increase in downwash at the horizontal tail. 4. A reduction in static source pressure leads to an increase in indicated airspeed. Best angle of climb speed, Vx, is the speed at which the airplane achieves the greatest gain in altitude for a given distance over the ground, usually slightly less than best rate of climb speed, Vi, which is the greatest gain in altitude per unit of time. The specific speeds for a given airplane are specified in the Federal Aviation Administration-approved airplane flight manuals, Pilot's Operating Handbook. Deviating by 5 knots from the recommended speed may significantly impact climb performance, emphasizing the need for precise control of airspeed during the maneuver. Despite the reduced drag and ground effect, it is crucial for the pilot to adhere to the recommended climb speed during takeoff. Attempting to climb out of ground effect below the recommended speed can result in decreased climb performance, especially under conditions of high density altitude, temperature, and maximum gross weight. Pilots must exercise caution to ensure safe and successful execution of the maneuver. Ground effect is valuable in normal flight operations, particularly for accelerating during takeoff from long runways or obstacle-free areas. When taking off from challenging surfaces, pilots can utilize ground effect to aid in initial acceleration and liftoff, adjusting the angle of attack to achieve normal airspeed before leaving the ground effect area. Short field takeoff and maximum performance climb. When taking off from fields with limited space or obstacles, it is essential for the pilot to maximize the aircraft's takeoff performance capabilities. This requires exercising precise control over the airplane's attitude and airspeed to achieve the shortest ground roll and the steepest angle of climb. The pilot must refer to and adhere to the performance section of the airplane flight manuals, Pilot's Operating Handbook, following the recommended power setting, flap configuration, airspeed, and procedures provided by the aircraft manufacturer. A thorough understanding of the best angle of climb speed, Vx, and the best rate of climb speed, Vi, for the specific make and model of the airplane is crucial for achieving a safe takeoff at maximum performance. The pilot should be well versed in these speeds and be able to apply them effectively to optimize takeoff and climb performance, especially when departing from constrained or challenging takeoff areas. Takeoff roll. Taking off from a short field necessitates initiating the takeoff from the very start of the takeoff area, ensuring proper alignment with the intended takeoff path. If recommended by the airplane manufacturer, the pilot extends the flaps to the specified setting before commencing the takeoff roll. This allows the pilot to focus entirely on employing the correct technique and monitoring the airplane's performance throughout the takeoff. The pilot should smoothly and continuously apply takeoff power without hesitation, aiming to accelerate the airplane rapidly. While some pilots prefer holding the brakes until achieving the maximum obtainable engine revolutions per minute before releasing for takeoff. The effectiveness of this procedure in reducing takeoff run in all light single-engine airplanes is not universally established. The airplane rolls with its full weight on the main wheels, accelerating to the liftoff speed. Throughout the takeoff roll, the pilot adjusts the airplane's pitch attitude and angle of attack to achieve minimum drag and maximum acceleration. In nose-wheel type airplanes, minimal use of the elevator control is required since the airplane is already in a low-drag attitude. Liftoff. As best angle of climb speed is approached during takeoff, the pilot should gradually apply back elevator pressure to achieve a smooth and firm liftoff, known as rotation. To maintain a constant airspeed, additional back elevator pressure is required as the airplane accelerates post-liftoff. Once airborne, the pilot maintains a wings-level climb at best angle of climb speed until all obstacles are cleared, or if no obstacles exist, until reaching an altitude of at least 50 feet above the takeoff surface. Subsequently, the pilot may slightly lower the pitch attitude and continue the climb at best rate of climb speed until reaching a safe maneuvering altitude. It's crucial for the pilot to avoid attempting to prematurely lift the airplane off the ground or climbing too steeply, as this may lead to settling back to the runway or contacting obstacles. Until reaching best angle of climb speed, the initial climb remains flat, diminishing the pilot's ability to perform a successful climb and clear obstacles. The goal is to rotate to the appropriate pitch attitude at or near best angle of climb speed. Some airplanes may naturally lift off before reaching best angle of climb speed, requiring the pilot to allow the aircraft to lift off in ground effect and then reduce pitch attitude until it accelerates to best angle of climb speed with the wheels just clear of the runway surface. This method is preferred over forcing the airplane to remain on the ground until best angle of climb speed is attained, as it minimizes nose wheel pressure and potential issues like wheel barrowing, aiding in acceleration and overall performance. Initial climb. During short field takeoffs, it is crucial to keep the landing gear and flaps in the takeoff position until the airplane has cleared obstacles, or as recommended by the manufacturer, and best rate of climb speed has been established. The pilot should refrain from adjusting landing gear or flap controls or looking inside the airplane for any reason until all obstacles are cleared. Once the airplane is stable at rate of climb speed, the retractable landing gear, if applicable, and flaps should be gradually retracted. Raising the flaps in increments is advisable to prevent a sudden loss of lift and the airplane settling. The pilot should then reduce power to the normal climb setting, or as recommended by the manufacturer. Common errors in the execution of short field takeoffs and maximum performance climbs include 1. Neglecting to review the airplane flight manuals, pilots operating handbook and performance charts before takeoff. 2. Insufficient clearing of the area. 3. Failure to use the entire available takeoff area. 4. Inadequate trimming of the airplane before takeoff. 5. Premature liftoff leading to high drag. 6. Unnecessarily holding the airplane on the ground with excessive forward elevator pressure. 7. Insufficient rotation resulting in excessive speed after liftoff. 8. Difficulty maintaining. 9. Excessive focus on the airspeed indicator during initial climb. 10. Premature retraction of landing gear or wing flaps. Soft or rough field takeoff and climb. In soft field takeoffs, operational techniques are employed to swiftly lift the airplane off the ground, minimizing drag caused by tall grass, soft sand, mud, or snow. This technique is especially useful when climbing over obstacles is required. It leverages ground effect to reduce landing gear drag and demands an understanding of the airplane's slow speed characteristics. These techniques are also applicable on rough fields to prevent damage to the landing gear. Soft surfaces like long, wet grass impede the airplane's acceleration during the takeoff roll, potentially preventing it from reaching sufficient takeoff speed using normal techniques. It's crucial for the pilot to recognize that the correct takeoff procedure for soft fields differs significantly from that used for short fields with firm, smooth surfaces. To mitigate risks associated with takeoffs from soft or rough fields, the pilot should promptly transfer the airplane's weight from the wheels to the wings during the takeoff roll. This is achieved by establishing and maintaining a relatively high angle of attack or nose-high pitch attitude as early as possible. Lowering the wing flaps before starting the takeoff, if recommended by the manufacturer, adds lift and facilitates the early transfer of weight from the wheels to the wings. The pilot should ensure a continuous motion with sufficient power while aligning for takeoff, as stopping on a soft surface, such as mud or snow, may cause the airplane to become bogged down. Takeoff roll. During the alignment with the takeoff path, the pilot should smoothly and promptly apply takeoff power, ensuring the power plant can accept it without faltering. As acceleration occurs, the pilot should employ adequate back elevator pressure to establish a positive angle of attack and diminish the weight borne by the nose wheel. Maintaining a nose-high attitude throughout the takeoff run is crucial. This practice gradually transfers the airplane's weight from the wheels to the wings as speed increases and lift develops, thereby minimizing drag caused by surface irregularities or adhesion. If this attitude is accurately maintained, the airplane virtually flies itself off the ground, becoming airborne but at an air speed slower than a safe climb speed due to ground effect. Liftoff. After the airplane becomes airborne, the pilot should delicately lower the nose with the wheels clear of the surface to facilitate acceleration to a minimum safe climb-out speed. It's crucial to note that immediately after becoming airborne and during the acceleration phase, the pilot should be vigilant. While transitioning out of the ground effect area, the airplane may exhibit a tendency to settle back onto the surface even with full power applied. Hence, it is essential to keep the airplane in ground effect until at least best angle of climb speed is reached. This necessitates a comprehensive understanding of control pressures, aircraft responses, visual cues, and acceleration characteristics specific to that particular airplane. Initial climb. After establishing a positive rate of climb and reaching rate of climb speed, the pilot should retract the landing gear and flaps, if equipped. In the case of takeoffs from airstrips with wet snow or slush, delaying the retraction of the gear allows for air drying, preventing potential issues. If there is an obstacle to clear after a soft field takeoff, the pilot should maintain the climb at best angle of climb speed until the obstacle is cleared. After clearing the obstacle, the pilot can adjust the pitch attitude to rate of climb speed, retract the gear and flaps, and then reduce power to the normal climb setting. Common errors in the performance of soft or rough field takeoffs and climbs include 1. Failure to review airplane flight manuals, pilot's operating handbook, and performance charts prior to takeoff. Inadequate back elevator pressure during the initial takeoff roll, resulting in insufficient angle of attack. 3. Neglecting to cross-check engine instruments for indications of proper operation after applying power. 4. Poor directional control. Of climbing too high after liftoff and failing to level off low enough to maintain the ground effect attitude. 6. Abrupt or excessive elevator control while attempting to level off and accelerate after liftoff, and allowing the airplane to mush or settle, resulting in an inadvertent touchdown after liftoff. 8. Attempting to climb out of the ground effect area before attaining sufficient climb speed. 9. Failure to anticipate an increase in pitch attitude as the airplane climbs out of ground effect. Rejected takeoff or engine failure. Emergency or abnormal situations during takeoff may necessitate a rejected takeoff while still on the runway. Malfunctions such as a power plant issue, inadequate acceleration, runway incursion, or air traffic conflict could be reasons for a rejected takeoff. Prior to takeoff, the pilot should identify a point along the runway where the airplane should be airborne. If that point is reached and the airplane is not airborne, immediate action should be taken to discontinue the takeoff. When properly planned and executed, the airplane can be stopped on the remaining runway without using excessive measures, such as aggressive braking that may lead to loss of directional control, airplane damage, or personal injury. The ground roll distances for takeoff and landing provided in the airplane flight manuals, pilot's operating handbook added together give a good estimate of the total runway needed to accelerate and then stop. In the event of a rejected takeoff, the power is reduced to idle and maximum braking is applied while maintaining directional control. If engine shutdown is necessary due to a fire, the mixture control should be brought to the idle cutoff position and the magnetos turned off. In all cases, the manufacturer's emergency procedures should be followed. In the event of an engine failure on initial climb-out, the pilot's first responsibility is to maintain aircraft control. At a climb pitch attitude without power, the airplane is at or near a stalling angle of attack. Simultaneously, the pilot may still be applying right rudder. The immediate response should be to lower the nose to prevent a stall while coordinating with rudder input to maintain controlled flight. The pilot should establish a controlled glide toward a suitable landing area, preferably straight ahead. Attempting to turn back to the takeoff runway is not advisable unless the pilot has received training for an emergency turnback and has sufficient altitude. Noise abatement. Aircraft noise issues are a significant concern at many airports, and local communities often advocate for the development of specific operational procedures to mitigate aircraft noise over nearby areas. In response to these concerns, many airports have implemented noise abatement procedures that include standardized profiles and practices aimed at reducing noise impact. Airports with noise abatement procedures communicate this information to pilots, operators, air carriers, air traffic facilities, and other relevant groups associated with the airport. Pilots can access these procedures through various means, including chart supplements, local and regional publications, printed handouts, operator bulletin boards, safety briefings, and information provided by local air traffic facilities. In airports where noise abatement procedures are in place, reminder signs may be installed at taxiway hold positions for applicable runways to prompt pilots to use and comply with these procedures during departure. Pilots unfamiliar with these procedures should inquire with the tower or air traffic facility for guidance. Regardless, pilots are encouraged to operate their aircraft considerately, aiming to minimize noise impact on the surrounding community while prioritizing safety. If you click like and subscribe and leave a comment, we will provide us coupon for a free PDF download of the book titled Airplane Flying or one of other ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.